Hi everyone, so today I wanna explain about the electron configuration. The electron configuration core elements, or also known as the noble gases, are the stable elements. Why is stable? Because they can hold the maximum number of electrons in their outermost shell. There are helium, neon, argon, krypton, xenon, and radon. The electron configuration of an element describes how electrons are distributed in its atomic orbitals. The electron configurations are useful for first determining the valency of an element, second predicting the properties of a group of elements. Elements with similar electron configurations tend to exhibit the similar properties. Subcells or sublevels refers to the set of orbitals in which the electrons are found. There are 4 sublevels. The first is sharp or S. It can hold 2 electrons. The second is principal or P. It can hold 6 electrons. Then the third is diffuse or D. It can hold 10 electrons. The fourth is fundamental or F. It can hold 14 electrons. The first example is the aluminium. The aluminium has 13 electrons. So if we want to make the electron configuration, first we from 1s, s can hold 2, so it becomes 1s2, then 2s2, and then p can hold 6 electrons, 2p6, then 3s2, then p can hold 6 electrons, but in here we only need one more electron to become 13 electrons, so we will make it become 3p1. And the second example is the electron configuration of the ion. Is asked for the chloride ion. The chlorine electron is 17 and the chloride electron is 18. In the ion, we need first to make the electron configuration of the parent atom. So in here the parent atom is chlorine. It has the 17 electrons. So first we make 1s2 and then 2s2, 2p6, 3s2 and then 3p5. And then in the chloride ion, the electron is 18, so we need to plus 1. So 1s2, 2s2, 2p6, 3s2 and then 3p6. The third question is the Fe2+. The iron electron is 26 and then the Fe2+ electron is 24. In here, we need to subtract 2 electrons. Also, like just now, first we need to make the parent electron configuration. So it becomes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And then after that, we can subtract 2 electrons. But if we want to subtract, we need to subtract the highest energy level. In here, the highest energy level is 4. So we subtract 2 from 4s2 become 4s0. So it becomes 1s2, 2s2, 2p6, 3s2, 3p6, 6s0, 3d6, or we also can make 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d6. Next, we're going to the guidelines in filling electrons among orbitals. First, is the Aufbau principle. Electrons will occupy the orbitals having lower energies before occupying the higher energy orbitals. According to this principle, electrons are filled in the following order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5e, 6p, 7s, 5f, 6d, and 7p. In here we can see the box is represent for the orbitals, and then every box only can hold 2 electrons. So first we can fill from 1s2 and then 2 electrons, 2s2, 2 electrons, and 2p5, 5 electrons. But first we need to fill the up arrow and then the down arrow. Then the Pauli exclusion principle, a maximum of 2 electrons is having opposite spins can fit in an orbital. So it must be the up arrow and down arrow. And then the Hans rule, every orbital in a given subcell is singly occupied by electrons before a second electron is filled in an orbital. Like just now I already say, so first 1s2 the up arrow and then down arrow, 2s2 up arrow and then down arrow, then 2p4 the up arrow, and then the down arrow. And then we also can find the electron configuration from the periodic table. How? So in here we will try from the carbon elements. First, we are going to 1s, 2, and then 2s2, then 2p2. Because in here carbon only has 6 electrons. And then is in the D block, so we need to subtract one number. So the first is 4D become 3D. So and then if we try the hafnium, so first 1s2 and 2s2, 2p6, 3s2, 3p6, 4s2, 3d 10, and then 4p6, and then 5s2, 4d10, 5p6, and then 6s2. And then in here we are going down to the alternate series, so going to the F element from 6 become 4, because in the F element we need to subtract 2 number, so become 4F14, and then going to 5D 1 2 3 4 5 1 2 5D2. And then there is also the family in the first vertical arrow is 1A, and the second 2A, third 3B, fourth 4B, then 5 5B, 6 6B, 7 7B, 8 9 10 is 8B, 11 is 1B, 12 is 2B, and then 13 is 3A, 14 is 4A, 15 is 5A, 16 is 6A, 17 is 7A, 18 is 8A. And in the F block elements, then the alternate series, and then the alternate series. The guidelines in predicting the periodic and groups using electron configuration. First, the outermost energy level of the element corresponds to its period. So the example 1s2, 2s2, 3, 2p5. So the outermost energy level is 2, so the period is 2. Number 2, the electronic configuration of the element ends in S or P, then the element belongs to family A. Otherwise, the element belongs to B. So in here 1s2, 2s2, 2p5. So it ends in the P. So it's family A. And then the third, for an element belonging to family A, the valence electron corresponds to the family number. So in here the outermost energy level is 2, and then the electron is the 2s2, 2 electron, and then 2p5, 5 electron. 2 plus 5 is 7, so it's family 7. This is the name of the family A. 1A is alkali metals, 2A is alkaline earth metals, the 3A is boron group, the 4A is carbon group, the 5A is nitrogen group, the 6A is chalcogen group, the 7A is halogen group, then the 8A is inert gases or noble gases. Then the family B, 2B to 7B is early transition metals. The 8B to 2B is late transition metals. The lanthanide series and actinide series is the inner transition metals. Now we are going to the quantum numbers. Quantum numbers are a set of numbers which describe every electron that are distributed around the nucleus, and then each electron has unique set of quantum numbers. There are 4 types of quantum numbers, namely principal, angular momentum, magnetic, and spin quantum numbers. The first is principal quantum number. Denoted by N is a quantum number that identifies the energy level of the electron being referred to. Example is 4s2. Then the 4 is the N, or energy level. So N equals to 4. Angular momentum quantum number. Denoted by L is a quantum number which corresponds to the sublevel. So it refers to the sublevel. Example 4s2. And then the sublevel is S, so the L equal to 0. And then the magnetic quantum number, denoted by Ml, refers to the orbital in which the electron is found. The box is 1, and the box represents for the orbitals that every box can only hold 2 electrons. The S, 1 box, so only 0, and then the P mean 1, 0 plus 1, the D mean 2, mean 1, 0 plus 1 plus 2, the F mean 3, mean 2, mean 1, 0 plus 1 plus 2 plus 3, or positive 1 positive 2 positive 3. And the spin quantum number, denoted by Ns, is a quantum number which specifies by the relative spin of an electron. If it's counter the clockwise, so it becomes positive half or 1 per 2. Then if it's clockwise, so it's negative 1 per 2 or negative half. These are the examples. The chlorine has an atomic number of 17. So first, we need to make the electron configuration of the chlorine. 1s2, 2s2, 2p6, 3s2, 3p5, or neon 3s2, 3p5. Neon in here represents for 10 electron. And then the first we find the period. The period is the highest energy level. In here is 3. And then the family, the N is P, so it's A. And then the valence electron is 2 plus 5 is 7A. And then it's halogen group. Next, we want to find the quantum numbers. So first, 3p5. The n from the 3 is equal to 3. So the L is equal to 1 because S is 0, P is 1. And then the ML is 0 because there is mean 1, 0, and then plus 1. And it ends in the 0. And then the MS is equal to mean 1/2. That's all I can explain about the electron configuration. Thank you.